This is one of the four that you must, this is one of the four that you must memorize. You already know one of them. The other one you know is 1 over x. What does 1 over 1 minus x equal? Is 1 plus x squared. So that's one of them. This is the second one. There's two more that you need to know, and they come specifically packaged very, very similar to this one right here. Very, very similar to this one right here. This right here is the Taylor series up here. And if it's around 0, right here, it simplifies nicely. This is called the, okay, so there's our definition for a Maclaurin series. So let's say f of x is equal to sine x. So what does f prime of x equal? Cosine x. What's f double prime of x equal? Negative sine x. And then f of 3x is going to be? And then if we go one more, what's the derivative of negative cosine x? It goes back. Yeah, so it's a cyclical for 4 of them, right? Okay, so we're not going to list an infinite amount of them by hand, because that's just not what we do. But if we wanted to actually write this series out, we need first know what is f of 0. Well, that's sine of 0, which is what? What is sine of 0? 0, right? So what is f prime of 1? Of 0, not 1. That makes it a lot harder to compute. Cosine of 0, what's cosine of 0? 1. Is that correct? Nice. Okay. So what about f2 of 0? It's going to be negative sine of 0, which is 0. And f3 of 0 is going to be negative cosine of 0, which is what? Negative 1. Okay. And then what happens after you do those first 4? They repeat. Nice. And then what matches up with, so f of 0 matches up with x to the 0 power. What does f prime of 0 match up with? X to the first, and then x squared, and then what? X cubed. And it's this over 1 factorial, this over, and this over. So what do we end up with? We now know that sine of x is approximately what? You multiply these, right? So what do you end up with? Well, 0, yes, 0 plus x over factorial, right? Mm-hmm. Let's skip the 0. So we can skip the zeros here, and let's move this over. Ah, it's going to be plus or minus next. It's going to be minus, so it's going to be x over 1 factorial minus cubed over 3 factorial. It's going to go plus minus, right? And you're skipping. Plus x to the 5th over minus x to the... So there's your approximation for sine x right there. So we could do the exact same work but for cosine, right? There's a simpler way, though. What could we do instead? What's one great relationship between sine and cosine? Better than that. What's the derivative of sine? Okay, so if sine is equal to this, let's take the derivative. What's the derivative of sine? Cosine. Thanks you for all at once there. Equals, what's the derivative of x over 1 factorial? 1. And this is going to be minus 3x squared over 3 factorial plus what? 5x to the 4th over minus 7x to the 6th over 7 factorial, right? What does that break down to? 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. Okay, so this right here represents the third one you must remember, and this right here. The nicer one right here. You must remember those. You must. They must be wrote. And here is a great way to remember them. Okay, you ready? Can you remember what e to the x is? What is it? X over 1 factorial plus x squared over 2 factorial plus x cubed over x to the 4th over 4 factorial. Okay, if you can remember this, sine and cosine are gimmies. Here's why. Sine x is a what function? Yes, true. What else? It oscillates. Doesn't really converge. It's an odd function. Do you agree with that? It's an odd function. So which numbers do you pick? So look at this. What powers do you choose? The odd ones. 1, 3, 5, 7, right? And it's always minus plus minus plus. And what is cosine? Is an even. It is an even function. It definitely is. It's okay. So that right here, these are the odd ones right here. Those are the odd ones. The even ones are those ones right there. And it goes minus plus minus. It goes first term is positive, and it alternates sign. Take a look. The first term is always positive, right? And then what's the next one going to be? Negative. It always goes positive, negative, positive, negative. So now can you remember all four of them? 1 over 1 minus x? 1 plus x squared plus x cubed. What about e to the x? 1 plus x over 1 factorial plus x squared over 2 factorial. Sine is odd, so you pick the odd ones and make it plus minus plus minus plus minus. Cosine is even, so it's going to go the even ones, plus minus plus minus plus minus. Does that kind of help you out right there? So here's the point. 2 points. One, if you know these functions, you can build ones that look similar to them. So for example, if I said x sine x, you know what sine x is, so what do you multiply all the terms by? X. If you have sine x plus cosine x, what do you do with the two series? Add them. So these are your building blocks. These are your elementary power series functions. And in particular, we like the ones that are centered around 0. So they're called what? Maclaurin. Does that make sense? Okay, ready? Smaller, yeah. Haha, your logic is flawed because I'm a jerk. And I got that on record. Okay, so here are the ones you really need to remember. The first 4 are the ones you really, tan is something you don't super need to know because you can derive it. But the first 4, absolutely. And then what is in parentheses right there? Yeah, what are these right here? Yeah, the intervals of convergence, which is the domains, yes. Yeah, arctan is pretty cool. So if I asked you to integrate that right there, it looks almost like something you could integrate. But if you didn't know power series, you're stuck because you can't use substitution. There's no x out front. There's no udv action. You're stuck, right? But let's rewrite this. What can we say? Well, we know that e to the x is equal to 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over. It's nice. Can't hurt to write it out once. So what is e to the negative x squared going to equal? 1 plus negative x squared over plus negative x squared over plus negative x squared over 3 factorial, correct? So what can we do now? Well, if we integrate the left, we should integrate the right-hand side. So if we integrate this thing, we're integrating this right here. So we're going to integrate, and I'll simplify now in the next line. We're going to integrate what? 1 minus x squared plus 1/2 x to the 4th minus 1/6 x to the 6th. And we can, what's easier to do if we're going to do this out? We could do 1/2 and 1/6 like this, right? And the thing is, can we write as many terms as we want? Sure. So now when we integrate this, though, what do we end up with? X minus 1/3 x cubed plus 1/5 x to the 5th, right? 1/10, because I can almost multiply. I just multiplied 1/2 times 1/5 and got 1/7. Awesome expert mistake. Oh, shush. 6. 1 over what? 1 over what? 1 over what? 42 x to the. So here's the thing. We now know the integral of e to the negative x squared is equal to this right here. You see that? Now, if we wanted to write this out more proper, so we can finish it like this. Like this is totally proper. What's the one last step we could take here? We could write this as a what? What notation is it called? We could write it in some notation, right? Notation, summation notation. So what's it going to be? You have to be careful. I mean, we can stop if this is going to be too hard, but it's going 3, 5, 7. So the powers are easy enough, right? So it looks like, what do we have here? We have the sum of n equals, let's say, 1 to infinity, right? So it's going to be x to the what power? x to the n over n factorial. Not no, let's do the powers first. It goes 1, 3, 5, 7. So what is that? 2n minus 1. So that is the x term, right? When x is 1 and then 2 and then 3, great. But then we have 1/3, 1/10, 1/40. So what does it turn into? So where does the 3 come from? What is the 3? So we need to find this. 1, then 3, then 10, then 42. But hey, the sign is changing, so it's going to be -1 to the what power? And let's say n minus 1, because it's starting at 1, right? So there's the alternating sign. But how do we do 1, then 3, then 10, then 42? What is that? What is it? Say it again. It's n times n. It's 1, then 3. I'll pause it here. It's going to be n minus 1 fact. Is this right? Check this for me. N minus 1 factorial times. I think that's right. In the denominator, yes. Sorry, no, I'm getting there. I'm getting there piece by piece. Is this right? I think this is good. Oh, I clipped that. I didn't mean to. How does this look? Did I get that right? Well, let's plug in 2. Plug in 2. What do you get? 2 times is 1/3, right? Plug in 3. What do you get? 4 times. Oh, I'm close. Should be what? Plus. Well, let's just guess it and see what happens. Well, look, here, we know this, right? We know it should be 1/10, right? And we know this part right here is going to be from what's 3 minus 1 is 2. 2 factorial is 2. So it should be 5. So 2n minus 1. Let's try that. I think this works. 2n minus 1 right there. Does that work? Let's just go to 42. What's 4 minus 1?
3.
What's 3 factorial?
6.
What's 2 times 4? 8 minus 1, 7. 7 times 6? 42! Yay! We got it! Sweet. So there they will ask you about error. We know that it's alternating, right? So and it's going to 0. So how do we figure out what the error bound is? So if we go to 5 terms or to 6 terms, the partial sum, if we go to 6 of them, if we do S6, what's the error bound for S6? The 7th one, whatever the 7th entry is, Bn or B7, right? Or whatever, A7, whatever you want to call it, right? So here's the thing. What you do to find this correct to 0, 0, 1 is you just find a term that's less than. Exactly. So what are your terms here? Your terms are, here they are. We have the first bunch of them, right? You see this? Correct? So for example, if you wanted to do S3, if you wanted to do S3 of this, what would S3 be? The sum of the first 3 terms, right? The sum of the first 3 terms. So if you do the first 5, just so you understand what you're doing, to do S5, what would you have to do? You're doing X, what was it? What was that series right here? It was this, right here. See this? You have to do the first 5 of them. What do you have to plug in for X? What do you plug in for X? If you do this out, if you do it to 5 terms, you end up with 0.7475. But then what you can do is you can find out what the 6th term is, like B6 right here. What is the 6th term going to be?
1 over 6 factorial.
Let's just be careful. So if we plug in 6, what do you end up with?
1 over 1320.
Yes, but it's x to the what?
Oh, x to the 11th.
X to the 11th, right?
Yeah.
-1 to the 5th over what? 5 factorial times what? 11. But what are we plugging in for 0? What are we plugging in for x? What are we plugging in for x? We're plugging in 1. Please don't plug in 6. So what's this going to be? It's going to be negative what? -1 over. What's 5 factorial?
That would be 120.
120 times 11. What's that equal to? -1 over what? 1320, right?
Isn't it the absolute value of this?
It is. Yes, it is.
Okay.
The error is, but I'm just calculating that one term, right? So we know that this right here, 11320, has to be the error bound. Sorry, excuse me. Write this here. The actual sum minus S5 has to be less than B6, which is equal to that right there. So what do we know? This right here represents our error bound, right? Our error bound. And what is this? Well, we know that the error bound is therefore going to be less than 1 over 1,320, but you know that that right there is less than 1 over 1,000, right?
Yeah.
And what is 1 over 1,000? 0.001. And I think that was how far it wanted us to go. There it is. It wanted us to go past 0.001. Does that make sense?
Yeah.
So we are closer than 0.001.